The complex process of the neuromuscular junction begins with the transportation of the action potential. This electrical impulse voyages down a motor neuron, thus reaching the axon knob. Following this transport, the synaptic vesicles in which contain acetylcholine, a neurotransmitter, will begin exocytosis through the synaptic cleft, beginning the docking process. This process involves the neurotransmitter, in this case acetylcholine, to attach onto the receptor of the motor end plate. This progression of acetylcholine onto the muscle cell will cause the action potential to begin on the cell membrane of the muscle, called the sarcolemma. The action potential impulse will then plummet down the T-tubules, which are responsible for spreading the signal throughout the surface of the cell evenly and quickly. This process creates electricity, and this electricity will then reach the sarcoplasmic reticulum. When this energy reaches the sarcoplasmic reticulum, it excites the structure, and in doing so, releases calcium into areas of filaments. The calcium that was released by the sarcoplasmic reticulum will bind to the tropomyosin cable. This cable will block cross-bridging sites located on the protein actin. After this process occurs, the tropomyosin cable moves to the side, causing the exposure of the cross-bridging sites, and from this actin exposure, the myosin head will lock onto the actin. After the myosin locks onto the protein, ATP is used to get that myosin head to perform a power stroke, which is the bending and pulling of the actin protein on top of the active myosin, thus overlapping and creating the contraction of the muscle. In return, a second ATP is needed for the release of the myosin, because contraction can't last forever, causing the relaxation of the muscle. After this entire process is finalized, it recycles for future contractions, followed by relaxation.